Slope is the steepness of the line. Yeah. Okay, slope is the steepness of the line. The easiest way when you're given a graph to figure out what slope is just pick 2 points on the graph, preferably where they cross on the grid lines, and just count them, right? Remember, slope is rise over run. Okay, or up or down over left or right. And algebraically or technically, the math term is the change of y, or delta y over delta x. Those are just Greek symbols. So I'm just going to count. How do I get from one point to the other? And it doesn't matter which way you go. So I'm going to go up 1, positive 1, and I'm going to go to the right, 1, 2, 3, 4. So my slope is 1/4. Positive slope because my line's going up. Positive slope. Let's do another one here. Let's do number 4. Slope is always a fraction. If it's a whole number over 1, you can leave it as a whole number. Just remember it's over 1. Okay, so my slope is going to go up 1, 2, 3, 4, and to the right 1, 2, 3, 4. Okay. Make sure you reduce all fractions for slope. 1 over 1, you could leave it like that, or put it in as a whole number 1. If I'm given 2 points, does anybody remember the slope formula? The algebraic slope formula? y2 minus y1 over x2 minus x1. Okay, and until, so you don't get confused, until you get used to it, I would label your points here. This is the first point they're giving me, so I'm going to call that x1, y1. This is the second point they've given me, so that's x2, y2. Those are just subscripts. So my slope is going to equal y2. My y2 is 12. Minus my y1, which is negative 11. Watch your signs. Minus negative 11 over x2, which is negative 15, minus my x1, which is 10. If you're one of those people that get confused real easy with the negative signs, use your calculators, okay? I have a double negative, that's going to make it a positive. So 12 plus 11 is going to be 23. Negative 15 minus 10 is negative 25. Make sure it's simplified. The thing that's nice about using your calculator, it can simplify it for you. This is simplified. Finding the slope of each line, all of these are in what we call slope-intercept form. And slope-intercept form is y equals mx plus b, where m is my slope and b is my y-intercept. What do I mean by y-intercept? That's slope. That's a definition of slope. So where my line, this is a linear equation, so it's a line. So where my line crosses the y-axis. The y-intercept is where the line crosses the y-axis. Okay. Number 9. So it wants us to find the slope of each line. And number 9, what's my slope? Remember, it's the m. Yeah, negative 3 over 5. It's the coefficient of x. So my slope here is negative 3 over 5. What's my slope in number 10? Yeah, negative 2, or you could put negative 2 over 1 if you want. Now 14, what's my slope? Yeah, it's 1/3. Now, this equation can be written another way, okay? This equation, sometimes they'll write it like this. X over 3 plus 1. Okay. Don't forget, if there's not a coefficient there, it's 1. So that's where we get the 1/3 and the x outside. A lot of times you'll just see x up on top. Your slope would still be 1/3. Just be careful. Sometimes it's a little tricky with that. Questions? All right, turn the page. Ooh. All right, these get a little hard. We need to put these in slope-intercept form first. In other words, we have to solve for y. And that's why we did a whole bunch of work with equations. All right. In other words, we got to get y by itself. So if I have 2x plus y equal 1, I have to get this y by itself. In order to do that, good, subtract 2x from both sides. Okay. I get y, bring down my y, I get y equals. Now, don't combine these. These are not like terms. You're supposed to be my 4th hour.
Yeah. Okay. See ya.
Huh? Okay, don't combine these. These are not like terms. And remember, my slope-intercept form is y equals mx plus b. Notice my x term is first. I'm going to leave this negative 2x first. Negative 2x, I'm going to put as my first term. Then it's going to be my plus b, or plus 1. Now this is the way we graph these. Here's my slope. Here's my y-intercept, right? The first thing we're going to do is put the point of the y-intercept on our graph. So where it crosses my y-axis? Well, positive 1. There's positive 1. My slope is negative 2, or negative 2 over 1. So am I going to go up or down 2? Down 2 from this point, and to the right 1. And I'm going to put a couple of points on here, okay? Down 2 to the right 1, down 2 to the right 1. Negative 2 over 1 is the same thing as 2 over negative 1, right? Yeah, Devon.
You know how you could get mistaken of going down left instead of right?
Yeah.
He said when you do that you cannot have like it's more like how you were saying negative 2.
Uh-huh.
He said you only can do like 1, 2, the right 3. So that means like if you was to say it was negative, you couldn't go 1, 2 to the left. That would be negative.
Hey, I think I know what you're asking me. Let me talk a little bit about this. Okay, when I have a negative fraction, and this is negative 2 over 1, that's a fraction. Okay, that negative sign can go with the 2, or that negative sign can go with the 1. Okay, these are all equivalent fractions. Now, I did it with, the first time I did the slope, I used this one, where the negative sign was with the 2. If I put the negative sign with the 1, well then I would have to go up from that original point of 1, I would have to go up to the left 1, because the minus sign is in front of the 1. Okay? Up to the left 1. Now, you're wondering, well, what's the difference? There really is no difference. Sometimes, though, when our slopes are a little crazy, like 8/5 or something like that, it might go off the graph in one direction. And we want to change it to the other direction so that we can get fitted on our graph. Now, speaking of which, when that happens, another way we could change fractions, suppose my slope was 4/5. Okay? Another way to write 4/5, negative 4 over negative 5. And again, it all depends on how it's going to fit on my graph, which one I'm going to use. Okay? They're the same, except one goes in one direction and the other goes in the other direction. That's all. Okay, so then I want to get a straight edge, and you guys are going to need a straight edge for Unit 6 because it's solving systems by graphing. I have rulers, but I like using my short little compass here because it fits these small little graphs. And here's my line. You're going to need a straight edge. Don't do it freehand when we start doing Unit 6 because we're going to be plotting 2 lines, and you're going to have to be reading these points off. And if you freehand it, you probably might get the wrong answer. Yeah.
That's what we're doing right now.
Now, numbers 19 and 20. You guys know that one's a vertical line and one's a horizontal line. Students usually don't have any problems with that. The problem comes, well, which one's which? And most of the times, both questions are on a test. So if you guess one wrong, you guess the other one. It's 2 easy points that you guys miss. Now, here's the way I tell the students to kind of, it's easy points if you do it this way. For every point every ordered pair, my x is 4. So here's x equals 4. Okay? My y can be anything it wants, but my x will always be 4. So what kind of line do I have? Straight up and down or vertical, right? So when I have x equals a number, x equals a number, it's a vertical line at that number. Okay. Well, y is going to be what? The horizontal one at that number. So that's going to be a horizontal line at that number. So here's -4, but I got to look at the y-axis this time, not the x.
Oh, okay.
Okay, here's my -4 in the y-axis. My y value is always going to be -4. Yeah, and it's unfortunate that if you, like I said, if you pick one wrong for one, you're going to probably pick the wrong one for the other. And it's 2 easy points you miss. All right, let's do a little bit harder one where we have to solve for y. These look pretty easy. Let's do 23. Okay, so I've got 3x plus 5y equals 15. I have to solve for y. I have to get this term by itself first. So I have a positive 3x. So how do I undo a plus 3x? Subtract 3x from each side. Good. These add up to 0. Yep, I'm going to bring down that 5y. Yeah, I want it in the y equals mx plus b form. So I'm going to put my x term first. -3x. This is a plus 15, positive 15. Okay. Now that I've got that term by itself, I still have to get y by itself. So how do I undo the multiplication of 5? Divide every term by 5. Yep, every term by 5. So my 5's cancel the 1. 1 times y is just y. Okay, here's my slope, -3/5. Okay, my x is in the numerator. I'm going to pull it out because it's in the numerator. I can do that so that I can easily read my slope. Positive 15 divided by positive 5, positive 3. Let's start with the y-intercept. My b is at positive 3. My slope is the coefficient of x, -3/5. I could put that negative sign with the 5 because there's only one of them. I'm going to try it, see if it fits on my graph. So it crosses my y-axis at 3. So my y-axis crosses at 3. My slope down 3. 1, 2, 3. To the right 5. 1, 2, 3, 4, 5. Here's another point. Now I like at least 3 points. but it's not going to fit on my graph. Let's try putting that negative sign with the 5. Okay. From my original point, I'm going to go up 3 this time, and to the left 5. Okay. And here's my line. We spent a lot of time on this last semester, and there's a reason for it, because we're going to get into systems, and you're going to have to be doing all of this. Okay. Any questions? The last page, or it's actually easy. You don't have to solve for y. It's already solved for it. Right. Or page 4. Yeah, I meant to put this section before the harder section, but that's okay. Like number 29. My b is 4. We don't have to solve for y because it's already by itself. My slope is -6. I always like it as a fraction. Okay, so my y-intercept is 4. Now this one looks like it's in the right, the negative sign's in the right place. So I'm going to go down 6 and over 1. Now I'm only going to get 2 points on this graph. That's it. So pages 4 and 5 are actually easier than pages 2 and 3. And I think I put the answers on this too as well, didn't I? Yeah. Yeah, that way you don't have to come up to the key book and you can just check your answers. This is review. This is a lot of what we did last semester. Yeah, we are going to have a quiz on this. Yeah. Questions? So your job, make sure the evens are done, okay? You have the rest of this hour. You got like 20 minutes. If you didn't get the other worksheet done, do that one first, then start working on this one, okay? I'll give you class time tomorrow, too, to work on these. All right, Jacob? Questions, comments, concerns?